Hi everyone. I created this little slideshow movie to help you understand how to diagram atoms. That's something that you'll have to do to fill out your Building Atoms worksheet and to take the quiz over that. So before you view this slideshow though, you should study Lecture A and then also get out your Building Atoms worksheet. You might want to refer to that while we go over this movie. So one of the earliest ways that an atom was diagrammed was something like this. It's called the Bohr model, and it was created by a guy named Niels Bohr back in the early 1900s. He imagined that an atom would be structured sort of like our solar system, where the in the atom the sun would be the atomic nucleus in the center, and around the atomic nucleus would be electrons that would uh, revolve around the nucleus, kind of like our planets revolve around the sun. So let's represent a nucleus, atomic nucleus, by this blue circle, and let's put a couple protons in there and a couple neutrons in there. And then let's add some orbits, orbitals, or shells. They're called those different names. And there's one, there's a second one. And then we'll put some electrons on there. Now, as it turns out, for one thing, the atomic nucleus doesn't have a particular perimeter. It's really just a region in the center of the atom that contains the protons and neutrons. And second, those orbits aren't like circular orbits, those electron orbits. They're really represent energy levels. And so whichever orbital an electron is in, it will have a certain amount of energy that will keep it a certain distance away from the nucleus, and it will always stay about that distance, but it won't be going in circles, just in a plane. The electrons will be buzzing around in all different directions. As long as they stay about the same distance from the nucleus, then they're good. And so it would look more like this diagram an atom would on the right. Let's go over the three parts of an atom. They're called subatomic particles: protons, neutrons, and electrons. Protons are inside the nucleus, so are neutrons. Each proton has a mass of 1. Each neutron has a mass of 1. Each proton has a positive charge, but neutrons have no charge, hence their name, neutrons. Electrons, on the other hand, exist outside the atomic nucleus. They have almost no mass, and they each have a negative charge that's equal and opposite to the positive charge of each proton. And that attraction between positive and negative charges is what helps hold an atom together. Now I want to diagram a simple atom, and I'm going to choose helium, He. Now this is how helium is represented in the periodic chart. There's a number on top, and before we get to that, let's represent protons with blue circles, neutrons with green, and electrons with red circles. So back to this number 2 at the top. That's called the atomic number. Every atom of helium has an atomic number of 2, and that means that every atom of helium has 2 protons in its nucleus. So the atomic number equals a number of protons in that atom. So let's put an atomic nucleus here and add 2 protons. Now, how do we figure out the number of neutrons? Well, that's a little bit more complicated, but not much. Let's take a look at the bottom number. That's the atomic mass. First of all, we're going to round that to the nearest whole number. So let's say the atomic mass is 4. The atomic mass consists of all the protons, which are each 1 mass unit, and all the neutrons, each of which also weigh 1 atomic mass unit. So the atomic mass represents protons and neutrons, their weight. So how do we figure out how many of these are neutrons? Well, we just take the number, the atomic mass 4, we subtract the number of protons, and what we're left with is the remainder, which is 2, and that's the number of neutrons. So we'll put 2 neutrons in that nucleus. Now let's add a first orbital. And how many electrons do we put on it? Well, what we have to remember is that the number of electrons always equals the number of protons. That's what makes an atom neutral. Overall, it's neutral. So we're just going to put those 2 electrons there, and we're done. There's our atom of helium. I want to say a little bit more about electron shells or orbitals. We're just going to take kind of a generic looking nucleus here and focus on the orbitals. The first shell or orbital can contain up to a maximum of 2 electrons. So it can contain 1 to 2 electrons. If there's more electrons in the atom, then you add a second shell. That second shell can contain up to 8 electrons. So anywhere from 1 to 8, but a max of 8. And then if you have more electrons, you're going to have an overflow into the third orbital, and it can also have a max of 8 electrons. Now there's over 100 different types of elements with 100 different types of atoms, and so there's many more electron shells that could be added. But we're going to keep it simple and stick with those elements that have that take up 3 or fewer orbitals, okay? So that would be what? A total of 2 electrons in the first orbital plus 8 in the second, that's 10, plus 8 in the third, that's 18. So anything more than 18 electrons or any element that has an atomic number of more than 18, we're not going to deal with. In fact, we're not going to deal with most of those. So to summarize, shell number, the first shell or orbital, electron max capacity is 2, and the second and third orbitals have a max capacity of 8. Okay, now let's test yourself here. We're going to take boron. There's its little chart in the periodic chart. So first thing we want to know is how many protons does boron have? So we're going to look at the atomic number. If it's 5, how many protons does boron have? That's right, it's 5, and we'll put that number in its electronic nucleus. In its atomic nucleus. All right, how do we figure out the number of neutrons in boron? Take a look at the atomic mass, round that to the nearest whole number, take that whole number, subtract the atomic number, which is the number of protons, and what we're left with is 6, which is the number of neutrons. So we'll put 6 neutrons in the atomic nucleus. Now, how do we figure out the number of electrons? The number of electrons is equal to the number of protons, which is the same as the atomic number. So there are 5 electrons. Put the first orbital in there, add 2 electrons. How many electrons do we still have to deal with? 5 minus 2 is 3. We've got 3 electrons left over. Let's add them to the second orbital, and we are done. That's boron. Okay, now that we know the structure of boron, or if we know the structure of any atom, we can figure out pretty closely how many covalent bonds it's going to form. So, how many can boron form? Well, first we have to understand the concept of valence. Valence refers to the outer properties of the outer shell or orbital, which is called the valence shell right there. I like to think of this shell as sort of the face of the atom that it shows to the world and which determines how many bonds it can form. The number of, or the electrons in the valence shell, those are the valence electrons. Okay, with that in mind, we know that boron, like all atoms, is neutral. That means the number of protons equal the number of electrons. However, because boron doesn't have a full valence shell, it is not stable. You are only stable and resistant to forming any kind of bonds if you have a full valence shell. If you don't have a full valence shell, an atom is going to want to form bonds in order to fill that shell so that it's more stable. And I like to think of this as it's more happy. So when it forms covalent bonds, it will share electrons with other atoms. That sharing will complete its outer shell and it'll be stable. So how many covalent bonds will boron make? Well, there's a little formula for this. So what is the full number of electrons that could fit into boron's valence shell? Well, it's a second shell, so if it were full, it would be 8 electrons. But how many electrons does boron have in its valence shell? We'll subtract that from the full shell, so it has 3. 8 minus 3 will give us the number of covalent bonds that boron will want to make. That's 5, because it's missing 5 from its outer shell, so it'll want to make 5 bonds. It'll want to share 5 electrons with 5 other atoms in order to complete that outer shell. So we've learned that boron has 3 valence electrons and that it can form 5 covalent bonds. Okay, let's talk a little bit more about this concept of valence electrons and how that determines the atomic stability or the happiness of the atom. So we're going to look at some trends in the periodic chart to help us understand that. So I've got a little compressed version or abbreviated version of the periodic table. And you can see here that it's got some columns. The number above each column indicates the number of valence electrons that every atom in that column possesses. So let's take a look at columns 3 through 6. All these atoms have 3 to 6 valence electrons, and they tend to make covalent bonds, which is what we were just talking about. They'll make covalent bonds in order to become stable. Well, how about this group over here? The last column on the right. This column, all of the atoms in that column have full valence shells. Most of them are full because they have 8 electrons, except for helium. At the top there, it only has 1 orbital, and that is full when it has 2. So these are all the inert atoms or the inert elements. They will not bond at all, okay? They're happy, they're stable. This is helium, neon, argon, the inert elements. Well, then there's another group here. Over here on the left, we've got columns 1 and 2. That's the number of valence electrons those atoms have. They, rather than form covalent bonds, they would rather just get rid of those outer valence electrons, get rid of that whole shell, and make the next inner shell be their valence shell, so to speak. So they want to get rid of, it's easier for them just to get rid of those extra small number of electrons. And when they do, they become ions, and they'll form ionic bonds. Similarly, over here on column 7, those atoms have 7 electrons in their valence shell. They're almost full. Now, it's not easy for them to get rid of all of those electrons. There's a lot of pull from those positive protons in the center of the nucleus. So instead, what the ones in column 7 want to do is they want to steal electrons from those kind of weaker ions over on the left side, and they'll grab them and they will form ionic bonds. So columns 1 and 2 will each lose 1 or 2 electrons and they'll become positive ions. In column 7, they will steal those extra electrons. So they're adding electrons, they'll become negative ions. And then, so the ions are charged atoms, and the positive and negative ones are oppositely charged. They'll attract one another and make ionic compounds. So there's our trend there. It's kind of interesting. Oh, I've got one more here. What happens with hydrogen? Well, hydrogen can make both ionic and covalent bonds. When hydrogen bonds with two oxygens to form water, those are covalent bonds. But when hydrogen forms a bond with, say, chloride to make hydrogen chloride, that's an ionic bond. So it's kind of unique that way. Well, I hope that helps clear things up. And now you should be ready to complete your Building Atoms worksheet and take your Building Atoms tutorial quiz. So good luck.